In today's session, we are going to see about visible surface identification. The concept of this visible surface identification, the name itself gives you that from a viewing point, you are going to identify the visible surfaces of the scene. That is, identifying those parts of a scene that are visible from a chosen viewing point. This is called as visible surface identification. And the classification of visible surface detection algorithm is of two types, based on whether you are going to deal with the object definition directly or with the projected images. The classification is done. The visible surface detection algorithm is classified into two. One is object space method and the other is image space method. In object space method, object definitions are used to determine the object space method. In image space method, projected images are used to identify the image space method to identify the visible surface of the object. In this, object definition is used to identify the visible surface. In this case of image space method, visible surface is identified by using projected images. Coming to the next point, image space method. There are 8 different types of image space method. One is back face detection. Second one is depth buffer method, and third one is A buffer method, and the fourth one scanline method, fifth one binary space partitioning tree method, and the seventh one is area subdivision method, and the eighth one is octtree method. The first method is called as back face detection method. What is back face detection method? Let us consider an object in which the back portion of the back side of an object is called as back face detection. Back face of an object, and to detect such back portion of an object is called as back face detection, which is an hidden surface usually, so that is not at all visible. So the visible surfaces should be identified by eliminating back face detections. So this can be done like this. That is, if my camera is viewing an object by this side and that is perpendicular to that it is normal to the view plane, and that plane is the inside plane which comes out of the backside portion, and this plane is called as, the backside portion is called as the back face, and it is detected, which should be eliminated. So this is what called as back face detection. And the next one is depth buffer method. This method is also called as Z buffer method. It detects visible surfaces in depth buffer method. So you can detect the visible surfaces by depth buffer method. In this case, a number of view planes can be identified. Surfaces of the view planes can be identified. That is, it is easy to implement. The method can be applied to non-planar surfaces also. Each surfaces of a scene is processed separately. So this surface of the scene is processed separately. That is, one at a time it processes across the surfaces. So that is why it is called as depth buffer method. There are two buffers used in this depth buffer method. One is depth buffer and the other one is refresh buffer. Depth buffer has some values to store depth values, and the refresh buffers used to store intensity values of the pixels. And the next one is a buffer method. A buffer method is annualized buffer method or area average buffer method. Accumulation buffer method can be given as A buffer method. This method is implemented in the surface rendering system, which is called as RES. RES is renders everything you ever saw. That is, whatever you see on the surface, that it identifies as visible surface. Whatever you don't see, that it will avoid it as hidden surfaces. Drawbacks of the previous method called as depth buffer is it only finds one variable surface at each pixel position. This can be overcome by the A buffer method, in which the advantage of A buffer method is it expands to many surfaces, in which the depth is greater than 0, which identifies that is only one surfaces it uses. If the depth is less than 0, which uses many surfaces, and the pixels identification can be notified here. And the next method is called as scanline method. This we will see in the next video. Thank you.